Welcome to Lesson 9 of Module 3, Biological Diversity. In this video, we're going to be looking at a few different examples of some modern day ecosystems and organisms where we can see examples of evolutionary change. The two examples which we're going to look at in this video and then explore more detail in our activities in the classroom are the cane toad and antibiotic resistant strains of bacteria. So, rapidly changing environments and small generation times contribute to a recipe for evolution, and it enables us to observe evolution by natural selection in action within our lifetime. So, the three examples which are listed here, there's the faster and larger cane toads, and these have been selected for the population of modern cane toads. There's antibiotic resistance, has been selected for in bacteria due to overuse and misuse of antibiotics. And some other examples are the tawny owl, the yellow-bellied three-toed skink, and the Mediterranean thyme. So the cane toad, it continues to reproduce and spread at a rapid rate across Australia, and we know that it has a devastating effect on native wildlife, including food availability and due to its poison glands. We do see in the population of cane toads the modern day, or what we also like to refer to as the frontier toads. They're larger, plus their legs are proportionally about 10 times longer and stronger. This means that these frontier toads move almost about 100 meters a day in straight lines, which is 10 times more than before. They have developed an ability to chemically detect the presence of their own species' eggs, and in areas inhabited by cane toads, other species are showing changes in their structural and behavioral characteristics. So they are, in fact, exerting a selection pressure, the cane toads are exerting a selection pressure on other organisms themselves. Antibiotic resistance. So antibiotics are chemicals that are used to inhibit the growth of bacteria or destroy them. And the widespread use of antibiotics threatens the successful future treatment of bacterial growth using antibiotics. So bacteria, through the normal process of natural selection, have evolved strains that are resistant to many, if not all, of the antibiotics that are currently used to treat infectious bacterial disease. The resistance that is seen in bacteria is complex because it's due to horizontal gene transfer. So bacteria can rapidly acquire genetic variation and new traits from unrelated species. When it's exposed to an antibiotic, the selection pressure, the bacteria that have variations that are best suited to that environment, so if they do in fact have the resistance to the antibiotic, they will survive and reproduce. Therefore, the population will become more resistant to the antibiotic over many generations. This situation has in fact arose from widespread misuse of antibiotics, including the use of low-dose antibiotics in livestock feed, inappropriate prescription, and also not finishing the full course. So here we just have a quick infographic of how antibiotic resistance spreads. So we can see that over our lifetime, the use of antibiotics and the way in which they're either used incorrectly, or we can see it in other places, it does affect human health, and we can actually see that occurring within a shorter span of time, as opposed to the evolutionary changes which we've looked at before, such as the horse and the platypus. That concludes Lesson 9, and it includes Module 3. Make sure you tune in for Module 4, which is the final module of the Year 11 course.